For years a single strange traveler has haunted the imaginations of astronomers and the public alike. An interstellar object that slipped through our solar system and vanished before we could answer its questions. First seen in October 2017 by a survey telescope in Hawaii, that visitor was unlike anything we'd catalogued before. It wasn't just another rock, it was a messenger from beyond. At discovery it seemed at first to be an ordinary wanderer. Small, fast, following a path determined by gravity. But as observations accumulated, the object's oddities grew clearer. An extreme, elongated silhouette, far more needle-like than spherical, stretched hundreds of meters in one direction but surprisingly slim across the other. Its shape alone made astronomers pause. And then came the motion. As it swept around the sun, the object changed speed in a way that gravity couldn't explain. Comets can accelerate when sunlight drives off volatile ices, forming jets that act like tiny thrusters. But astronomers found no coma, no dust, no detectable gas emission. No conventional explanation fit. For some, the idea that it might be engineered, a piece of technology rather than a lump of rock or ice, moved from fringe to a serious line of inquiry. The notion that we might have briefly observed an artificial craft was discussed openly in scientific circles for the first time in modern memory. Then, as quickly as it had arrived, the object receded, racing back out into interstellar space and fading beyond reach. The mystery remained. For years it sat in the catalogues of the unexplained, a riddle with no solution. Now, that riddle has returned. A new observing network, dozens of smaller observatories connected by AI-driven sky scans, recently flagged unusual motion at the far reaches of the system, out in the distant cloud of icy bodies at the solar system's edge. What emerged from the noise was startling. Multiple bodies moving together, one of which showed the same reflective character, rotational behavior, and tiny speed variations that matched the data from the 2017 visitor. Even stranger, their trajectory wasn't simply a straight inbound path from the stars. One object appears to have looped, as if it intentionally turned and come back toward the sun. Under known celestial mechanics, without a massive unseen planet to sling it about, that behavior makes no sense. The formation is not solitary. Several smaller companions accompany the lead body, flying in a loose V-shaped arrangement that shifts subtly as they respond to one another. The kind of coordinated motion you expect from systems under guidance, not from random piles of rubble. Then the lead object began to emit a faint, rhythmic glow in the infrared. It wasn't a radio signal, it wasn't microwaves or something our usual antennas would pick up. The pulse was thermal and patterned, repeating like a heartbeat, a kind of emission we do not normally see from inert rocks or comets. If this pattern is deliberate, it changes the conversation. For decades scientists have assumed space is mostly mute and objects move under gravity's rules alone. This behavior, returns, formations, coordinated motion, and patterned infrared pulses, suggests intention. Some researchers now speculate that the object observed in 2017 was never solitary but part of a larger system, perhaps on a reconnaissance sweep. The unexplained acceleration we once chalked up to hypothetical outgassing could instead have been a purposeful maneuver, a calculated burst of thrust during a quick flyby. If that was the case, the present return feels less like chance and more like a deliberate revisit. There are other hints that something unusual is happening. Instruments monitoring the solar wind report subtle, repeating fluctuations that appear to sync with the incoming object's infrared rhythm. Whether that's a byproduct of their passage, an interaction with our space environment, or evidence of some advanced capability, shielding, propulsion, or something else entirely, remains unknown. No radio messages aimed at Earth have been detected so far. If communications are happening, they might be in forms we haven't yet learned to listen for, or perhaps they are not intended for us at all. The signals could be exchanges among the objects themselves, or responses to something already present in our system that we have yet to identify. The announcement landed with an odd mixture of calm and gravity, the kind of measured voice you hear when someone is used to translating complicated truths for the public. Its words were precise, almost clinical, but the implication was anything but ordinary. Something strange, something deliberate, was moving through our solar system. Within hours that message catalyzed action. Laboratories, observatories, and mission control rooms that normally operate in separate orbits of competition and priority began sharing data as if bound by a single, urgent mandate. Telescopes were retasked. Archived observations were dragged back into the light for reanalysis. Algorithms worked through years of survey images looking for the faintest echoes that might connect the new sightings with old anomalies. It was a moment when the routine, bureaucratic machinery of science accelerated into something resembling coordinated emergency response. Engineers sketched rapid response concepts on whiteboards. Could a small, agile probe be launched on short notice? Could existing spacecraft be retasked to act as scouts? Astronomers rerun orbital solutions, searching for intercept windows or gravitational quirks that might explain the visitor's odd movements. At the same time, ethicists, diplomats, and legal scholars convened to ask blunt questions. Who decides how to approach a potentially artificial object? What protections do we owe to our own planet? How much information should be public, and when does transparency risk panic or misuse? Out in the public sphere, reaction was immediate and varied. Some greeted the news with wonder, a confirmation of a hope that has echoed throughout human imagination for centuries. Others bristled with unease, imagining scenarios drawn from fiction, hidden agendas, unintended consequences, the unknown. Newsrooms did what they always do, amplified both the reasoned and the sensational. Meanwhile, classrooms filled with new conversations, philosophers wrote long essays, and ordinary people debated the implications in cafes and comment threads. The cultural fabric vibrated with the possibility that we might finally be sharing the cosmos with something else. Scientifically, the questions are precise and many. The object's approach through the asteroid belt is not random. That region is a dense library of rock and metal, the frozen record of our system's formation. If these bodies are scanning, the belt offers abundant material to examine, from primitive carbonaceous fragments to metal-rich cores stripped by past collisions. Are they cataloging composition? Searching for manufactured anomalies? Or simply passing through a region of historical significance? The difference matters. Natural probes probing composition require different instruments than an intentional craft designed to investigate specific artifacts. Then there is the behavior itself. One body appears to have reversed course, not the kind of gravitational slingshot we model routinely, but a loop that implies control beyond chance. Accompanying it are smaller companions that move in loose, coordinated formations, adapting subtly to each other's motion. And the most startling detail recorded by infrared arrays. A faint, repeating thermal pulse, regular, patterned, and unlike known thermal emissions from inert debris. Taken together, these attributes push us into two very different interpretive camps. The first seeks explanations within nature, perhaps a rare class of interstellar object with unusual shape and composition, interacting with sunlight and sublimating volatiles in ways our detectors struggle to catch. The second admits the uncomfortable possibility of agency. That these are not random objects but systems under guidance, using maneuvers, formations, and rhythmic emissions to perform tasks we do not yet recognize. Both approaches are scientific. Both demand attention. If the objects are natural, priorities include detailed compositional spectroscopy, high-resolution shape modeling, and dynamic simulations to update our models of small body physics. If they are intentional, higher risk but potentially higher reward actions come to the fore, close approach imaging, in situ sensing, and efforts to decode the cadence of thermal pulses. all while balancing planetary protection and diplomatic concerns. Practical planning has already started. Mission designers run through contingency scenarios. What if fragments break free and threaten existing spacecraft? What if interaction with the visitors triggers unexpected environmental effects in near-Earth space? Collision avoidance plans and data sharing protocols move from theoretical exercises to active operational needs. This is science knitting itself to policy, because a challenge of this magnitude cannot be solved with telescopes alone.